Hello, students. Welcome to KENE'S Educare, a group of KENE solutions. This is part 8 of lesson number 1, Atoms and Molecules. So, as in the last class, we discussed on writing the chemical formulae. We even discussed on how to write the formula of some simple compound. Now, though both the things were very important because, as you know, as I stated that in the last part as well, where because you will be having the same thing, like writing the chemical formula is like writing the alphabets in English. Because if you don't know the alphabets, you won't be able to write a word. You won't be able to write a statement. Same way, if you don't know the symbol of the elements, you won't be able to like start with anything. So that is why it plays a very important role that you know the symbols of the elements, you know how to write the chemical formula of the compounds. Okay, so before starting with, like, today we will be discussing about the molecular, like molar mass, we'll be discussing on mole. Even we will be discussing on the relationship between the molar mass, mole, and Avogadro's number. And then we have like 11 questions all together to discuss, right? So that is how we will be ending up with the lesson. But for now, I want you all to please have a very quick revision on all the slides that I'm going to show you one by one on screen. And I hope each one of you are going through it. So here we have information on ancient Indian and Greek philosophers, right? So I just want you all to please go through this because this is the basic thing that we have started the lesson with. Then we even studied about the law of chemical combination, where we have studied two important laws, that is law of conservation of mass, and the other law that we have studied is law of constant proportion, right? So I just want each one of you to please go through it once. So this is the law of conservation of mass, which states that mass can neither be created nor be destroyed in a chemical reaction. And this is the activity that supports, you can say, the law of conservation of mass, right? After this, we had studied the law of constant proportion. So I just want each one of you to please go through it. After this law of constant proportion, we discussed on John Dalton as well. Like, he was born in a poor family, poor weavers family, in 1766. Then he started his teaching career early at the age of 12, where he further became the principal of school. Then he moved to Manchester for teaching mathematics, physics, and chemistry to college students, right? And while teaching, he was even like doing his research, because of which he came up with his atomic theory in 1808, which is known as atomic Dalton's atomic theory, or we even call it as postulates of Dalton, right? So these are the postulates of Dalton that we have studied so far, and I want each one of you to please go through it once. Then, after studying the postulates of Dalton's atomic theory, we discussed on what exactly is an atom, right? So the smallest tiny particle of matter, which we cannot divide it further, the you can say the particle which is in like which we cannot divide it further, we call that as atom. And atom is the smallest building block of matter, right? And we have different examples which include sodium, hydrogen, oxygen. These are different examples of atoms, right? Then we discussed on like how big are atoms, so we discussed about the atomic radius over here. And now we know that we measure atomic radius in nanometers, right? So 1 meter is equal to 10 raised to 9 nanometers, and we have and different examples of it, right? So I just want you all to go through it. After this, we discussed more about like what are the modern day symbols of atoms of different element, right? So this is the table that you can see of like the symbols of some of the elements which were proposed by Dalton. But after that, Berzelius he came and he suggested that symbols of elements we can make it from one or two letters of the name as well, right? And that is how like we have the symbol system that we use nowadays. We don't use this because this is a bit confusing as well. So instead of this symbols, this was given by Dalton. And as like this all the things were studied, you can say it was like because nothing much was known during the study of Dalton. That is why like he came up with his representation, but for further after it got like changed according to Berzelius' suggestion, and now we everything that we follow is according to IUPAC recommendations, right? After this, like we discussed more about the IUPAC recommendation and now how we go with IUPAC recommendations, and instead of writing the symbols we use the first or the second letter of the, you can say, of the name, right? So and always like we have certain rules to follow. The first letter of the symbol it shall be always written in capital letter, and the second letter should be written in small letters, right? After this, we discussed on the symbols of some elements, right, which have been given over here. So I hope till now, like, it's becoming easier for you to identify the elements with the symbols. I hope everyone has been through it. Then we discussed on atomic mass in detail. So here we have some of the important points, but important points are mentioned over on this screen, right? So just go through it once and then you can even go through the next slide. Okay, so after this, like, this is the important slide. I just want you all to please go through it once. After this, we even like elaborated it more, so I just want you all to please go through it once. Then we discussed on the atomic mass of some of the elements. I want you all to please go through this slide as well. After this, atomic masses of few elements, we discussed on like how exactly the atoms exist, right? So we studied that atoms, they are not able to exist independently. They're always going to form molecules and ions, and when these molecules and ions they aggregate in large number, they're going to form the matter that we can see, feel, and touch around us, right? After this, we discussed on like what is a molecule, right? So molecule is made up of like two or more atoms which are chemically bonded together, and they have been held tightly together by the attractive force. Okay, and always remember, like, we can define this molecule as smallest particle of an element or a compound which is capable of an independent existence, and it has all the properties of that substance. So atoms of same element or of different elements, they can always join together and they can form molecule. Okay, so I just want each one of you to please go through it, because like we have the examples over here as well given, so I just want you all to please go through it once. Okay, I hope everyone is going through the slide on what is a molecule. After this, like, we studied on molecules of elements as well, so I just want each one of you to please go through it once. So if you remember, we have a table on monoatomicity, diatomicity and all, right? After this monoatomicity and diatomicity, like, we have this table where we have the atomicity of some of the elements. Like for phosphorus, we know that it is tetraatomic, right? Then argon is monoatomic, oxygen is diatomic, sulfur is polyatomic. This is the atomicity that you should be knowing, as this can be asked as objectives as well, right? So I just want every one of you to please go through this table once. After this, we discussed on the molecules of compound, right? So under this molecules of compound, we had different compounds along with the combining elements given in ratio by mass, right? So when it comes to water, which we represent it as H2O, the combining element present in water is hydrogen and oxygen, and the ratio by mass is going to be 1:8, right? When it comes to ammonia, the combining elements of ammonia are hydrogen and nitrogen. So the ratio by mass is 14 is to 3. And when it comes to carbon dioxide, the combining elements present in them is carbon and oxygen, and they are been present as 3 is to 8 ratio by mass, right? So I hope now you are very much clear with all these concepts as we have studied it so far, right? Then we had this activity 3.2 as well, where we were representing the ratio by mass of an atom which is present in molecule, and that has been given in table 3.2 for the atomic masses, right? So I just want each one of you to please go through this activity as well. After this, we discussed on what is an ion, and we said it that ion, it can be negative or it can be positively charged, right? So a negatively charged ion, we call it as an ion, and a positively charged ion, we call it as cation. After this, we discussed on the combining elements of some of the ionic compounds like calcium oxide, magnesium sulfide, and sodium chloride, right? Then we discussed on writing about the chemical formulae. So I just want each one of you to please go through it once as well, because this is very important, as I said with you with respect to postulates of Dalton's atomic theory, writing the chemical formula, like you can get a note on it as well, like to write a note on it. So make sure you're knowing the rules and everything, and you can write a note on it. Okay. After writing this chemical formula, we discussed on the valencies of some compounds. I just want each one of you to please go through it once. Then this is what we have studied in the last class regarding the formula of simple compound, right? So here we have more examples. I want each one of you to please go through it. After this, now we will be discussing about the molar mass and the mole concept. So see, what is molar mass now? In session 3.2.2, we discussed the concept of atomic mass where you remember, if you remember, like we had some of the elements and their atomic masses were given, right? So this concept can be extended and we can calculate the molecular mass using atomic mass, okay? So the molecular mass of a substance is the sum of atomic masses of all the atoms in a molecule of the substance. What is molecular mass? Molecular mass is sum of atomic masses of all the atoms. Okay, so like suppose if I have if I have like example H2O, and when I add up, now we know the combining element like which are present in water is hydrogen and oxygen. So when I add up the atomic masses of hydrogen and oxygen, I will calculate, like I will be able to calculate the molecular mass. But for that, I need to know the atomic mass of hydrogen and oxygen, right? So it is therefore the relative mass of a molecule, and we express the molecular mass in atomic mass unit, that is U. How do we express the molecular mass? In atomic mass unit, and we represent this atomic mass unit as U. Now here we have an example given 3.1 where we need to calculate the relative molecular mass of water. Okay, now as I said, if we have to calculate the molecular mass of water, we should be knowing the atomic mass of the constituting elements or the combining elements that we have. Okay, so let's see. Now we know the atomic mass of hydrogen is 1 atomic mass unit, and for oxygen it is 16 atomic mass unit, right? So to calculate the molecular mass of water, which contains two atoms of hydrogen, now how many atoms are there? What is the formula that, like, how do we write water? H2O. It means there are two hydrogen and one oxygen atom, right? So it becomes 2 into 2 hydrogen into atomic mass of hydrogen is 1 plus 1, there is only one oxygen, so 1 into atomic mass of oxygen is 16. So when you calculate this, you get the answer as 18 atomic mass unit. Got the answer? How to calculate the molecular mass? For calculating the molecular mass, you should be knowing the chemical formula of that, and even you should be knowing the atomic mass. You can say, firstly, you should be knowing the chemical formula. Secondly, you should be knowing the atomic, you can say, mass of every combining element of that compound. Okay. I hope now you got it how to calculate the atomic mass. After that, the second example that we have is to calculate the molecular mass of HNO3. Okay, so see, for that, for calculating the atomic mass of HNO3, what is needed? We need atomic mass of H, we need atomic mass of N, and we need atomic mass of O, right? So the atomic mass of H is 1, that is hydrogen ka atomic mass is 1, nitrogen ka atomic mass is 14, and that of oxygen ka atomic mass is 48. Now why 48? Because there are 3 HNO3. 3 is there, right? Atomic mass of oxygen is 16. So 16 into 3 becomes 48. And when we do the sum of it, we get the answer as 63 atomic mass unit. Got it? I hope you're getting an idea of how to calculate the molecular mass. But for that, you should be knowing the atomic mass and you should be knowing the formula of it. Okay? So I want you all to you might have written the first one, even checked it. For second one also, I want you to calculate it on your own. After this, we have formula mass you need to discuss. So see, the formula mass of a substance is a sum of atomic masses of all the atoms in a formula unit of a compound. Now when it comes to formula mass unit, it is like you have to add on all the atomic masses of the atoms in a formula unit. Now as we were doing the same thing with water and HNO3, right? What we did, we just added up, we summed up the atomic masses of all atoms in a formula unit, right? So formula unit mass is calculated in same manner as we calculate the molecular mass. How are we going to calculate the formula unit mass? In same manner as we calculate the molecular mass. And there is only one difference over here, is that we use the word formula unit for those substance whose constituent particles are ion. Okay, instead of using molecular mass, we use formula unit over here for substance whose constituent particles are going to be ions. Now, let's say, for example, sodium chloride, as discussed above, has formula unit as NaCl, right? So, how can we calculate the formula unit of NaCl? Now we know sodium and chlorine. How many sodium and chlorine are present over here? There's only one. So 1 into atomic mass of sodium is 23. And how many chlorines are present? Only one. So 1 into atomic mass of chlorine, that is 35.5. And when you sum up that, you get the answer as 58.5 atomic mass unit. Got it? So this is how we calculate the formula mass unit. So instead of using the molecular mass, we use the term formula mass unit over here, and this is how we calculate it. Getting it, everyone? So I just want you to write the difference between the molecular mass unit and the formula mass unit, and even you can give the heading as formula mass unit of NaCl and just write this equation. After this, we have the next concept as the mole concept to discuss. Okay, so see, take an example of reaction of hydrogen and oxygen to form water. Okay, we know that when hydrogen and oxygen they combine in a specific ratio, that leads to the formation of water molecule, right? So let's say like this is a balanced equation that they have given. 2H2 plus O2, when they combine together, it leads to formation of 2H2O2. Okay, now the above reaction of water, it indicates that two molecule of hydrogen combine with one molecule of oxygen and they form two molecules of water, right? Just look at the reaction while I'm saying you this. Two molecules of hydrogen are combining with one molecule of oxygen to form two molecules of water, right? Or you can say 4 atomic mass unit of hydrogen molecule combine with 32 atomic mass unit of oxygen molecule and they form 36 atomic mass unit of water molecule. So here we are representing it in case of atomic mass unit, right? So we can infer from the above equation. See, when you state in both the way, both the reactions that have been stated, they both are correct. We can read it in both the ways, right? So we can infer from this above equation that quantity of a substance can be characterized by its mass or by the number of molecule. How can we characterize a substance? By its mass or the number of molecules it have, right? But a chemical reaction equation, it indicates directly the number of atoms or molecules which are taking part in the reaction, right? Whenever we have a chemical reaction or a equation of a chemical reaction, it indicates us that it is directly the number of atoms present in the reaction, right? And therefore it becomes more convenient for us to refer to the quantity of substance in terms of its number of molecules or atoms rather than their masses. Because of the second statement, if I take first, I will have to calculate the masses and then I'll give you the second statement, right? But when it comes to the first statement, where you see two of hydrogen are combining with one molecule of oxygen and they form two molecules of water, right? So that is more convenient to use when we are using the quantity of substance in terms of its number of molecules it have, right? So for this, a new unit called mole was introduced. Okay, what was introduced? There was a new unit called as mole which got introduced, and we symbolize that as MOL. Okay, so MOL is the SI unit of the amount of substances. Now mole, how do we represent mole? By the SI unit MOL. So 1 mole contains exactly 6.022 into 10 raised to 23 elementary entities. Now you don't have to remember such a lengthy number. It's like how do we represent 1 mole? How many like elementary entities are present in 1 mole? It contains 6.022 into 10 raised to 23. This is how we know it. Okay, so this number is the fixed numerical value of the Avogadro's constant. What it is, we know it as the Avogadro's constant. Now if you have been asked to write Avogadro's constant, how do we write it? Avogadro's constant is 6.022 into 10 raised to 23. Okay, and always remember that this number is going to be fixed numerical value, and we know it as Avogadro's constant. Okay, where when expressed in the unit per mole, it is called as Avogadro's number. So if I just add 6.022 into 10 raised to 23 unit per mole, then that becomes the Avogadro's number. Okay, so the amount of substance that is represented as symbol N is a measure of number of specified elementary entities, that how many elementary entities are present in it, that has been represented by the symbol N. And an elementary entity may be an atom, molecule, ion, an electron, or other than that, it can be any other particle or specified group of particles in it. Okay, always remember that elementary entities can be anything. It can either be an atom, molecule, ion, electron, or any other particle. Okay, so mole is the amount of substance of a system that contains 6.022 into 10 raised to 23 specified elementary entities. How many how much amount of substance is present in 1 mole? It contains 6.022 into 10 raised to 23 specified elementary entities altogether. And always remember, 1 mole of any element of anything is going to be equal to 6.022 into 10 raised to 23 number. As we know that when it comes to 1 dozen, how do we represent that 1 dozen? We say that there will be 12 numbers in it, right? And when it comes to 1 gross becomes equal to 144 numbers, right? So same way, this mole, how do we represent that? 1 mole of anything is going to be equal to 6.022 into 10 raised to 23. Getting it? I hope now you are clear with this mole concept in detail. Mm. So I'll discuss further about mole in the next part. Like I was supposed to complete it in this part, but I will not elaborate it much. Okay, we'll like study the mole concept and the relationship between all the three in the next class, because like, or else let me just complete it and then we can start with relationship in the next class. Okay, see, beside being related to number, a mole has one more advantage over dozen or a gross. Now we know dozen is equal to 12 numbers and gross is equal to 144 numbers, right? But there is an advantage with respect to this mole, and the advantage is that mass of 1 mole of a particular substance is also fixed, right? So when it comes to mass of 1 mole of substance, it will be equal to its relative atomic or molecular mass in grams. What this 1 mole of substance will be equal to? Relative atomic or molecular mass in grams. Okay, so the atomic mass of an element, it gives us the mass of one atom of the element in atomic mass unit. What does it give? Like if I suppose I have the atomic mass of an element, what it is going to give us? It is going to give us mass of one atom of that element in atomic mass unit. Okay, so to get the mass of 1 mole of atom of that element, that is the molar mass, we have to take some numerical value, but here the unit will change from U to G. Instead of using the unit as U, atomic mass unit, it is going to change to gram atomic mass. Okay, what it will be changing to? It will change to gram atomic mass. For example, we have over here is atomic mass of hydrogen is 1 atomic mass unit, right? But when we are saying the gram atomic mass of hydrogen, it will become equal to 1 gram. 1 g means 1 gram atomic mass unit. Okay, so 1 u hydrogen has only 1 atom of hydrogen, and 1 g gram atomic mass hydrogen will have 1 mole of atoms. That means it will have 6.022 into 10 raised to 23 atoms of hydrogen. Okay, similarly, if I consider 16U oxygen, it will have only one atom of oxygen. But if I say 16G oxygen will have 1 mole atoms. That is, it will have 6.022 into 10 raised to 23 atoms of oxygen. Getting it, everyone? So I just want you to write this thing in your book and keep, because this is very important. You can get some of the, you can say, objectives on it, important objective questions on it. So make sure that you know this, okay? Okay, now see. To find gram molecular mass or molar mass of a molecule, we keep the numerical value the same as the molecular mass, but we are just changing the units. Okay, it is the same thing. It's just that instead of writing the unit as U, we are writing the unit as G. For example, as we have already calculated, the molecular mass of water is 18U, right? So from here we understand that 18U water has only one molecule of water, right? How much? 18U water will have one molecule of water. 18G water will have one mole molecule of water, and that is 6.022 into 10 raised to molecules of water. So here now chemists need the number of atoms and molecules while carrying out the reaction, and for this they will have to relate that to mass in grams to the number. So it is done as follows, like 1 mole we know it is equal to 6.022 into 10 raised to 23. number, right? And this mole is equal to relative mass in grams, and thus a mole is the chemist counting unit, like we calculate using the normal addition subtraction, that is the math, right? But this is not math, this is the counting unit of a chemist. Okay, so I just want you all to write this thing. I hope everyone is writing it. I hope everyone has understood this concept of Avogadro's number. Now, see, the word mole was introduced around 1896 by Wilhelm Oswald, who derived the term from the Latin word moles, meaning a hip or a pipe. Okay, what does it mean? It means hip or a pipe. So, a substance may be considered as a hip of atom or molecule. What can we consider it? We can consider any substance as a heap of atoms or molecules, and that is what we know it as a mole. Okay, so the unit mole, it was accepted in 1967 to provide a simple way of reporting a large number, that is a massive heap of atom or molecule. So if there is a massive heap of atom or a molecule in any of the sample, we represent that n we represent that as a mole. Getting it, everyone? So you can just write some points on it as well. After this, like the relationship between mole, Avogadro, and mass, I'll be continuing that in the next part, not today, right? So I'll be continuing with this, the relationship between mole, Avogadro number, and mass. And along with that, we have like three different examples, okay, which we will be discussing on it. So I'll be doing that right in the next class only. So we have these three examples to discuss, and after that, we have the summary discussion to do in detail, like what exactly we studied in the whole lesson, atoms and molecules. We will be doing the study, like summary discussion on that, and then we have 11 questions to discuss in detail, which I'm going to show you one by one now, and I want you all to please go through them properly because you will be answering me in the next part. Okay. So these are the 11 questions that we are going to discuss at the end of the lesson, atoms and molecules. Okay, and I want like each one of you to be very much clear with whatever we have studied so far. So as like we have like elongated one more part to the session, make sure you are revising everything properly and you're making sure that every question which has been asked you're able to answer them. Now I have shown you all the questions, right? So you should be able to answer them. I will be telling you the answers, like what you can write over here, okay, and how you can calculate the ones. I'll be helping you with that as well, but make sure you are doing it on your own as well. Okay, don't depend on me now, because I have already taught you the whole lesson. So you should be knowing how to calculate it now. Okay, so this is how we are going to end up with the lesson atoms and molecules. Now, whatever part has been left, I will be continuing that in the next part. Thank you, everyone.